When we were solving equations, sometimes we had to use the multiplication and division principles to solve for the unknown variable, and we're going to do the same with inequalities. We want to, though, take note of the sign of the number that we're either multiplying or dividing by. If the number is a positive number, then we'll continue to work it the way that we've been doing. And so, for instance, if I had, say, 2 is less than 8, that's an inequality. And if I were to multiply, say, 3 to both sides, we would find that this inequality will continue to be true. And so 2 times 3, that's going to give me 6, and 8 times 3 is 24. And you can see, in fact, 6 is less than 24, and so this continues to be true. The issue is, though, when I multiply or divide by a negative number, you're going to find that that's, if we don't change the symbol, that the inequality turns up to be false. And so I want to give you an example. Let's say that I take this 2 and 8, and instead of multiplying by 3, positive 3, let's multiply by a negative 3. So we're going to start with 2 times negative 3, and we're saying that's going to be less than 8 times negative 3. Well, 2 times negative 3 is negative 6. 8 times negative 3 is going to be negative 24. And if I were to say that negative 6 is less than negative 24, you might be scratching your head. Well, no, that's not correct. Negative 6 is closer to 0. So if I were to draw out a number line, and just, I'll just throw in some numbers here, try to make them equal here. So let's say this is 0. Let's say this is negative 6, negative 12, negative 18, and negative 24, and so on. You can see that the negative 6 is closer to the 0. The negative 24 is further away. And so this is actually a smaller number than this one here. And so this would be false. Okay? Oops, false. So what we want to do whenever we're multiplying or dividing by a negative number, we want to change that symbol. We want to reverse it. So instead of less than, we're going to put negative 6 is greater than negative 24, and then that would be true. All right, so what I'm going to do is go through a couple of examples, multiplying and dividing by positive and negative numbers, and also I want to graph and I want to check. I want to check my work. Checking is really a good skill to practice, and you'll find maybe over time it will make sense what we're doing here if this is still fuzzy. So I want to divide by a positive number, and we'll see what we come up with. Let's say that in this example we have 5 times a number is less than 8. Okay, again, what we're doing is we're solving for x. We want to isolate x, so we're going to use inverse operations. That hasn't changed. So this is 5 times x. We're going to divide by 5, or I guess you could multiply by 1/5. I'm going to go ahead and divide by 5, both sides. This is going to cancel, and we've got x is less than 8/5. And we can also convert that to a mixed number. Or, you could say 1 and 3/5. Okay? Now, oh, darn it, I keep writing that. Let's say less than, not less than or equal to. Okay, now I'm going to graph it. Just do a quick sketch here. Let's say this is 0, this is 1, 2, -1, -2. Okay, let's see. So if this is 1, 3/5 is a little more than half. So I'm gonna kind of estimate it's there. Notice this is less than not less than or equal to, like originally I mistakenly wrote. So we're just going to draw an open circle, okay, and every number that's less than this amount is a possible solution. So we're going to go ahead and thicken this line or darken it, and all the way to the negative to infinity, okay? And so any number on this darkened arrow here, or this line, is going to be a possible solution. Now let's go ahead and check. Alright, so I'm going to pick 1. Let's just pick, I'm not going to deal with fractions, let's just pick a nice easy one. I'll pick 1. 5 times positive 1, is that less than 8? Well, 5 times 1 is 5, and sure enough 5 is less than 8. Okay, now if we had picked, say, 2, you're going to get an inequality that is incorrect. So I'll do that real quick just so you can see it. If I pick 2, 5 times 2, is that less than 8? Well, 10 is not less than 8. So no, that's why graphing after you figure out what the value of x is will help you pick a number to then plug in and check. You know, that's the reason why I graph first. Okay, let's move on to some other examples. All right, let's say we have, let's work with a negative. So let's divide by a negative number. And again, we're going to just make it easy here. So we'll go with negative 3 times a number, and I'm going to say that's less than 15. Okay, negative 3x is less than 15. Like before, I want to divide by whatever this number is that's associated with the x. And again, if you want to multiply, you could multiply by negative 1/3, but I'm going to divide by negative 3 both sides. That's going to cancel. I'm left with x, and then 15 divided by negative 3 is going to give me a negative 5. But what we want to remember is that if we're multiplying or dividing by a negative, we want to reverse that sign. So instead of less than, we're going to write it as a greater than. Okay, x is greater than negative 5. So let me go ahead and graph that. Just draw a quick sketch here of a number line. And I'm going to say this is negative 5, negative 6, negative 7, negative 8, and then go in this direction, negative 4, negative 3. Okay, you don't necessarily need a 0, you just need a range of numbers based off of that number. So now this is greater than, not greater than or equal to, so it's going to be an open circle. So first find negative 5, here it is, open circle, or an open dot, wherever you want to say it, and x is going to be greater than negative 5. So that means I'm going to the right of that negative 5. I'm going to kind of darken that line, all the way darken the arrowhead. So any of these numbers that are greater than negative 5, I'm going to, or are possible solutions for this inequality. Now let's go ahead and check. Let's pick one of those numbers to make sure that's correct. And let's say negative 4. Okay, negative 4 is, you know, in this darkened area, so I'm going to choose negative 4. So I've got negative 3 times negative 4. Is that less than, or yeah, less than, not equal to, 15? Let's see. Negative 3 times negative 4 is a positive 12. And you know what? 12 is less than 15. So this is true. And so it was a good idea that we changed or reversed the sign, because when we plugged in a number greater than negative 5 into the original inequality, we came up with a true inequality. Okay, let's do some more because this takes some practice. Okay, let's say we've got a negative 1/2 times a number, and we're going to say this is greater than 10. Negative 1/2 times a number greater than 10. I'm going to go ahead and multiply both sides by the inverse of this 1/2. So that'd be basically I'm multiplying by 2. But again, this is a negative 1/2, so I might as well multiply it by a negative 2. So negative 2, or 2 over 1, times negative 1/2 x is greater than 10 times negative 2. These, of course, are going to cancel. Negative times a negative is a positive, so I've got a positive x. Okay, and 10 times a negative 2 is a negative 20. And just like the last problem, because in the last problem I was dividing by a negative number, here I'm multiplying by a negative, so this needs to be reversed, and I'm going to write it as x is less than negative 20. Let's go ahead and graph that. Let's see, I'm just going to put down a few numbers here. Let's say this is negative 20, and I'll count by tens, negative 30, negative 10, 0, and positive 10. So I want to first identify negative 20. This is less than, so it's an open circle, and all the solutions are going to be less than that number. So I'm going to the left on the number line. Okay, now I want to find a number and then plug it into the original inequality. So I'm going to pick an even number because you know, that's going to be easier to work with. Let's say we go with negative 30. Okay, negative 30. So negative 1/2 times negative 30, or negative 30 over 1, because we're dealing with fractions here. Is that greater than 10? Okay, well, if I reduce, 2 goes into 30 15 times, and negative times a negative is a positive, so I'm going to have 15 is greater than 10. And you know what? That is true. So it was good that I reversed that symbol, because when I picked a solution that was less than this number and then plugged it back into the original inequality, I came up with a true inequality, and that's what we're gearing for. Let's see if I have any other examples. I think that might be the last one in this set of problems. In the next video, I'm going to talk about combining principles to solve inequalities, and so that will be kind of a step up from what we've been doing here. If you have more questions, please bring them to class and we'll go over some more examples.